This is lesson 10.2, the area of triangles and trapezoids. A diagonal can divide a parallelogram into two congruent triangles, that is, two equal triangles. Excuse my crooked line there. So the area of a triangle is 1/2 the area of a parallelogram. So you could take 1/2 times the area of the parallelogram, and you could calculate the area of the triangle. Now the altitude of a triangle is the perpendicular segment from a vertex to the line containing the opposite side. So in other words, you're going to go from the vertex all the way straight down to the base. Make sure it's meeting the base at a right angle. And the height of that line is going to be the length of the triangle. You can see that better in this triangle at the bottom. The base is that length sideways across the bottom. The height is going to be from the opposite vertex straight down to the base at a right angle. So it's not the length of either one of the sides that are opposite the base. It's actually a line dropping from the vertex straight down to the base. The area of a triangle is 1/2 the base times the height of the triangle, or 1/2 b times h. So we're going to find the area of this triangle. You can see it's 3 centimeters high. The sides that are coming down, AC and AB, are 5 centimeters, and the base is 8 centimeters. Well, to find the area of a triangle, the length of the sides are really irrelevant. What you want to find is the area, and the area is the base times the height times 1/2. So we're going to take that equation and insert the numbers that you're given in the problem. So here, the area is going to be 1/2 the base, which is 8 centimeters, times the height, which is 3 centimeters. So your area is going to be 12 centimeters squared. Area is always squared, remember, because it's unit times unit. That's how you get squared. So make sure you always get your units correct here. In this case, it's centimeters, so the area is centimeters squared. Let's find the area of this triangle. This is a right triangle. Its base is 5 meters, its height is 2 meters, and the hypotenuse is 5.4 meters. Well, the area of a triangle is 1/2 the base times the height. So the area is 1/2 times 5 times 2, or 5 meters squared. Let's look at a real world problem here. We're looking at a house, the side of a house. We have the roof line, the triangle part at the top, and then we have the actual base of the house. We want to know how much siding does the builder need to cover the side of the building, and that includes that roof line there. So here you have to calculate the area of both the triangle and the rectangular base. So we're going to do it in two parts. We're going to calculate the area of the base, which is actually just the length times the width. Remember, that's just a regular rectangle area. So it's 16 times 10. That's 160 feet squared. The area of the triangle part at the top, I gave you the height, which is 9 feet tall, and you have to figure out what the base is. Well, the base of that triangle is the same as the width of the rectangle at the bottom, so it's 16 feet. The area of the triangle would be 1/2 the base, 16, times the height, which is 9, which is 72 feet squared. So you're going to add both the areas together to get the total area of the side of the house. 160 plus 72. That's 232 feet squared of siding. Now let's find the area of a trapezoid. Well, the area of a trapezoid is sort of tricky because you need to look at a trapezoid like two triangles. We're going to divide it in two triangles by taking a line across, and in this case I drew it from A to C. These triangles have the same height of 4 centimeters, but they have different bases. So we're going to add these two areas together to get the area of the trapezoid. We're going to assume in this drawing, even though it's a little off, the D is a right angle. That's why I drew the square there, so you could see it's a right angle. And we're going to calculate the area of each triangle and add them together to get the area of the trapezoid. So the area of ADC is 1/2 times the base times the height. So it's 1/2. The base is 6. The height is going to be 4, the same as the height of the green line, because we're assuming that's a right angle, AD, so that height is the same as from C to the base, that's 9 centimeters. So you're going to take 1/2 times 4 times 6, and that equals 12. The area of ACB is 1/2 the base times the height. That's 1/2 times 9 times 4. So you're going to see that that's 18. So you add both sections together, and you get the total area of 30 centimeters squared. In a trapezoid, remember the parallel sides are the bases of the trapezoid. You have got a bottom base and a top base, and those lines are parallel. Well, if the bases are B1 and B2, let's say, let me move this so you can see it, and the height is H, then the area is going to be 1/2 times B1 times H and 1/2 times B2 times H. But if you use the distributive property, you can change this equation around a little bit and rewrite it. The area is actually 1/2 the height times the quantity of B1 plus B2. And this will make things a lot easier, so you don't have to divide trapezoids into triangles all the time. Although that will always work as well. This is just a shortened version, an easier way to calculate the area of a trapezoid. So we're going to look at this real-world example, and we're going to look at calculating the area of a cross-section of the Erie Canal. The Erie Canal is shaped like the diagram in the middle of the page here. It's 4 feet deep, and it's 40 feet across at the surface of the water, and 28 feet wide at the base. So you can see the walls go in at angles. So this is a trapezoid, and this picture is called a trapezoidal cross-section. So it's a little side view of what the inside of the canal looks like. So we use the formula for the area of a trapezoid. The area of this cross section is going to be 1/2 the height times the addition of both bases. So take 1/2 times 4, and then the two bases are 28 and 40. When you add those together, it's 68. So the area is going to be 2 times 68, or 136. So the area is 136 feet squared. Remember, we started with feet. We're multiplying feet by feet, so that's how we got feet squared.